What is up, my fellow gabbers? I am coming to you this Friday, November 4th, to talk about Operation Donut Hole. Now, this was a post I put up a couple days ago. I took it from this video. Well, maybe we'll look at this video here in a minute. But my question was, why in this video is this image of Sirius? Well, why is Sirius shaped like a donut? And in this case, with a bite taken out of the donut here. And we got some interesting responses. It's a frame of something constantly moving, vibrations. Look at some sand on I guess you call that Chladni plate, vibrating different frequencies, making the sand move. Maybe that's what's going on here. We got some boobs. And then we have some pictures of candle flames flickering. I don't know what's going on here. I don't know what a ferrocell is. This looks like just some cheap starburst filter in front of a solar eclipse. And not one person, well, Scope Man here, he knows the truth. The stars are donuts. That's the actual answer. But the answer that I was looking for, of course, never comes up. And the answer is that it's not shaped like a donut. But in this picture, the shape of the donut is coming from somewhere else. So let's take a look at that original video just so we can see if we can get this to play. I can skip this ad in 5, 4, 3, 2, 1. We're going to
Germany
skip to the end here. I think it was at about 45.
For signs and for seasons and for days and years, and let them be for lights in the firmament of the heaven to give light upon the earth. And it was so.
Yes, the sun is bathing in the clouds here in just a moment.
And God made two great
We'll see
lights,
some stars.
the greater light to rule the day, and the lesser light to rule the night. He made the stars also.
So this is Sirius. I'll pause this for a second if I can. Notice here we have the distinct donut hole in the middle. At some point, this image changes real quick, and I'm not sure why. If they inserted another lens or a Barlow or something into the telescope, but let's see. Right about here, I believe. I'm not sure if this is the same telescope even, but I think it is. But now you've got this bite missing here that wasn't there a second ago. But as we see, yeah, you see some the light fluctuating, pulsating, whatever it's doing. But the donut shape is there. It's not moving. The donut is the donut. So this is not just it happens to be you caught the still frame of the donut. The donut is the shape that we're seeing, regardless, in the video. And my question
God
was,
set
why?
them in the firmament of the heaven to give light upon the
Venus,
earth,
according
and
to
to
this
rule over the
video.
day and over the night, and to
Probably
divide
taken
the
with
light
same
from the
telescope.
darkness.
And notice there is
God
no donut
saw that it was
hole
good.
in Venus here.
And the
which is
evening and the
interesting,
morning
so we'll
were the
talk
fourth
about that.
day.
So that was the original video. Sirius, why did it have a donut hole, I asked. And the consensus seems to be nobody can know why there's a donut hole. So just accept the fact that it's there and make something up. But we have some knowledge among us as the human race. We've experienced things, we know things, and I think we can come up with a better answer than we don't know where donut holes came from. So let me get rid of this thing here. Let's take a look again. Well, let's do this. I tell you what I'm going to do. I'm going to pull this up here. This was a picture that Photomaniac had posted earlier today, and I'm assuming that's fireworks because it looks like fireworks to me. I think he would say that this was a picture of fireworks. But what if somebody came and said, that's not fireworks, that's what NASA wants you to think fireworks look like. This is what fireworks really look like right here. What would you say to that person? I know I would say that possibly is fireworks. It very much looks like fireworks, but it looks like it's out of focus. Your fireworks are out of focus. That's why it looks like that instead of the other picture that we just saw. And if somebody said, no, that's just what actual fireworks look like, and if you try to tell me anything else, you're a NASA shill, I would just have to write that person off as an imbecile. But that's because I know what fireworks look like, right? We've seen fireworks. And I know that that picture that I just showed you is out of focus. It's not what fireworks actually look like if your camera is in focus, right? But what about something that we don't know what it looks like? Can you know if something that you've never seen before up close is in focus or out of focus? Is it possible to even determine that? And I would say, yes, it is possible to determine that because we know how focus works. We know how cameras work. And I took some images, I took some video the other night from my telescope, posted a picture of a shot from one of them just to show you what I was doing. But let me pull this video up and let's take a look at some of the things that are going on in this video. First, I'm going to show you my telescope. And that's a cruddy picture because it's taken in the dark with my cell phone. Um, but what it is a 10-inch Dobsonian reflector, which just indicates the type of mount that it's on. It's a Newtonian reflector. You have a mirror at the bottom of the telescope. Down here, this is the primary mirror. It's a 10-inch mirror. And then at the top here, you have another mirror. This is a little secondary mirror. And what that does is it takes the light that comes into the telescope, hits this mirror, bounces back up to this mirror, which is at an angle, and reflects it through this tube here to the eyepiece that you would have on the outside there of the telescope. And then you would focus it with this knob here that would just cause this tube to move in and out in order to get the focus adjusted. I'm not sure if this picture is any better. Same thing. You're looking at the large mirror at the bottom, the primary objective mirror, and then you have the secondary mirror. And you might notice something about this arrangement here, is that you have this obstruction here in the middle, and you have these metal vanes that are holding that mirror suspended above the primary mirror. And does that look like anything that we've seen? Anything at all? You see these lines here, and this thing here, and this thing here? Does that look familiar at all? In this picture, do you see this thing here sticking in? And this, and this? So, what I'm postulating to you is that that donut shape is not the star. It is the aperture of the telescope that is being used to take the picture of the star, and the star is out of focus. And that is why the star appears to have the shape of the aperture of the telescope. Now let me go ahead and get these videos out. If I can close some of these things here. Can I close these? I'm no good with computers anymore. I'm getting old. Okay, here we go. So close all this stuff. Let me open up this video. So this is a star I was filming Capella the other night. And right now, as you can see, the star is small. Pause it. It's twinkling. You have some little spikes coming off of it here. We call these diffraction spikes. I'm not sure how well these are going to show up in the video, but on my screen up here I can see them fairly well. But let's let this play a little bit. Now I'm taking this at about 10 to 15 frames a second. Here I'm going to start adjusting the focus. I'm racking the focuser out. And you see the stars getting larger. I'm not zooming in or anything. There's no zoom feature on my telescope. All I'm doing is adjusting the focus. The camera being moved in and out so that the focal plane is further or closer to the camera sensor. As I rack the focuser, you see the stars getting bigger and it's starting to show all this spiky electricity looking stuff here. Now here you got these concentric rings that you can see if you can see in between the lasers, and you've got the donut hole in the middle. Now I'm having to manually adjust. Here I'm adjusting the exposure a little bit so it's not so bright, so you can see better what's going on here. Now the telescope, like I said, is manually tracking. I'm not tracking at all. It's just sitting there, so the star is going to drift across the frame, and I'm going to have to move it every once in a while to keep it in the frame of the camera here. So in a minute, I think I'll lose the frame for a second, and then I have to get it back. Anyway, so I'm going to adjust the focus some more, I believe, in this set here. We'll just let it play. Oh, here we go. What is that? You see that moving around there? Is that what the star really looks like? Or is that something else? Get some more bigger star here. All I've done is put the star further out of focus now. The star gets bigger on the camera sensor because it's further out of focus. And as I said, I've lost the star. I had to re-find it here. Just take a second. There it is. So the further that I take the star out of focus, the bigger it appears on the sensor. And you can see all that flashing and flickering in there, but it's out of focus. It's 100% out of focus. I've got it so far out of focus now that I don't think I can get it any further out of focus. This is as far as the focuser will travel. I turn up the exposure a little bit. You see this wavy line stuff going on here. And here in a second, I'm going to do something. I can show you this spot right here. I believe is a water spot that's on my mirror that has been there forever. And so it's not reflecting light from that particular spot on my mirror. And that's why you have a little dark spot there. But here we go. I'm just changing the exposure again. You notice it moves a little faster when it gets brighter because it's taking less frames per second. I'm running this thing at 10 frames a second, I believe, but the actual frame rate is variable as I change the exposure. Oh, what's that? That is so weird. Is that what Sirius really looks like? Does it look like my hand? No, that's my hand. I'm putting my hand in front of the telescope, and you can see the heat coming off of my hand causing ripples in the air in the image, making it look like it's underwater. All that is just from me putting my hand in front of the telescope. My hand is not particularly hot. It was not particularly cold that evening, but you have heat that causes air drafts to move in cases like this. This other little thing here is actually a tree limb that's between my telescope and Sirius. It just happens to be moving in front of it. I couldn't even see it in the dark, but I've got a bunch of trees in my front yard. And so you see that tree limb just moving across the star there. You wouldn't see that if it was in focus. You wouldn't see my hand if it was in focus. You won't see the donut hole if it's in focus. We'll let this thing play some more. I'm not sure that there's a whole lot more that we need to see on this, but I took the video. We might as well watch it, right? I've got some more video of something else that we'll look at after this. So here we're racking the focuser now. We're taking it back into focus. And you notice that we can get it down to a point. We can't get it any smaller than that. If I rack the focuser, continue to go the same direction, it'll go out of focus again. But it'll be, the focus travel will be in the other direction. So you got in focus and out focus, I guess. And I can go either way, but I can only go so far in one direction. I can go further in the other direction. I think this is as far as I could get it to go on the in focus. Then I rack it back the other way. I can get it much bigger going the other way. But one thing you might see here in a second, I think I put my hand again in front of this as I'm doing this, and you'll see that the image gets inverted when the focuser is moved from one direction to the other past the focal plane. Come on. Again, in focus, the star is small. When we take it out of focus, the star gets big. That's just that's just basic photography. You should understand that when if an object is in focus, it's going to be as small as you can get it. Okay, here, all I've done here is I've increased the exposure, which makes the frames longer. So now you can see there's another star right here that you couldn't see before. I'm going to increase the exposure even more here in a second, and it's going to start moving really fast because it's taking frames over a second long. That's why you're getting this blurring. So there's multiple stars in this image that you were not even able to see because the exposure time was not long enough to register them on the sensor. And of course, when you increase the exposure that much, the main star that we're looking at, which is really bright, is way overexposed. Um, so if you had that out of focus, you wouldn't even be able to see those other stars because they're faint and they would be just smudges of light that would not even register on the sensor at all. Where are we at? Okay, so again, I'm taking it out of focus. I believe here in a second I'm going to put my hand in front of it again. There's my hand coming in from the bottom of the image. And now here I'm going to rack the focuser in and go the other direction. Now my hand's upside down. See that? It flipped. The image flipped when I changed the focus direction from inward to outward. And that's probably enough of this. I don't know if there's anything else that I can show you here that have. Oh well, I don't remember. Did I do this? Let me go back here. When I put my hands in front of this, I don't think I pointed this out. There's again the heat coming off my hand. When I move my hand out of the way, I'll do here in a second. Move the hand. Come on. Now, once I move my hand out of the way, come on, move your hand. Now I'm blowing. I'm just blowing hot air out of my mouth across the frame or across the opening of the telescope. And that's what's causing all that motion that you see there. It's just the air. The movement of the air bends the light in ways that cause it to shimmer and look like it's underwater because it's out of focus. Again, you wouldn't see that when it's in focus. But that's all that is. It's just air currents causing all of that motion that you're seeing inside that what we call a bokeh image there. And I'll explain that in a little bit. So let me close that and let's look at this other video here. Open this one up. Do I have them both open? This is a different object that we're looking at here, and you might be able to figure out what it is, but I'll just tell you what it is. This is Jupiter and its 4 moons, the Galilean moons that are readily visible through a telescope. Now Jupiter, you may notice, does not have a donut hole. But you see that little donut hole on all these moons. So what I've got here is they're just slightly out of focus. Got the exposure up bright enough that they're easy to see the moons. Normally if you have the exposure properly exposed for Jupiter, the moons are going to be very faint. So we'll see that here in a bit. But as I adjust the focus, you see again the moons are getting bigger. The donut hole is readily apparent on these moons. Something else I want you to notice, if you look at these moons, we'll look at these 2 right here. You'll notice that they have the same features going on in them. You see this little light wiggle over here, you see the same little light wiggle over there on that moon, because they're all that light coming through from those moons into the telescope is going through the same column of air, and they're very close together, and so they basically are copies, carbon copies of each other. As you see this little line here, line here, line here, line here, they're identical, because what you're seeing is not what this moon actually looks like. What you're seeing is the light reflecting off the mirror, going through all the air currents and coming to a non-focused plane on the camera sensor, and it's what they call a bokeh image. It is
The unfocused light takes the appearance of the aperture of the camera or the telescope that you're looking through. That's all you're seeing. And again, like I said, you don't have that donut hole on Jupiter because Jupiter is not a light, not a point source of light. Jupiter is a body. It has a disk that is readily apparent. You can see it, and when you take it out of focus, it doesn't get that crisp bokeh image. You get it gets blurry, but because I've got the exposure up so high, it just looks like a blue ball. But we'll take the exposure down here in a bit, and we'll get a better look at Jupiter. Go ahead and skip through some of this. So here we're getting a little closer to focus. Now we're just about focused here, and I'm going to take the exposure down. And you see those moons are almost just points of light. They're so small. I'm not sure how well they're showing up on the video, but on my screen I can see them. The Jupiter, though, you can now see some detail, the banding and the clouds there. And we take the exposure back up again so we can see the moons. Go ahead. Now here I'm going to take Jupiter way out of focus. And you see that it does indeed have that donut hole, but it's blurry. It's not crisp and well defined because, like I said, Jupiter is not a point source of light. Jupiter is a full disk, and so you're getting the whole image of Jupiter smeared around in this donut, basically. But it does indeed show the same feature. The secondary mirror blocking that center of the mirror at the bottom of the telescope is what's forming that hole in these images when they're out of focus. And that's one way you know they're out of focus because you're seeing that donut hole. If you had a telescope and you looked in it and you said, all I can see is donuts everywhere I look, you call the telescope company, they're going to say you need to adjust the focus. If you're seeing the donut, it's because you're out of focus. That's all it is. So, can you know if something is out of focus if you don't have a donut hole? Yes, you can. Again, I showed you that when you rack the focuser, when the image is in focus, everything is going to be as small as it can possibly get. When you rack that focuser and the star gets smaller and smaller and smaller and finally gets to a point where it starts getting bigger again, you've passed focus. You rack it back the other way. You get that star as small as you can get it. That is focused. And that applies to any object. If you can make that object smaller, then it's not in focus. That's just how focus works. You have a cone of light that is coming into this telescope here and bouncing up to this mirror, coming through here and going to this eyepiece. But basically, where the focal plane is, that light source, that cone of light, is going to be at its smallest point. This is kind of, I don't know, simplistic illustration. But basically, when it's in focus, that cone of light is going to be as small as it's going to get. And then once it goes past that, it's going to start going the other way again. It's going to get bigger. So, so anything that you can make smaller in your eyepiece or in your camera is out of focus. It's not on the focal plane. That's just camera 101. If you want to know how to focus something, that's how you do it. You make it as small as you can. If you don't know what it looks like, make it as small as you can, and whatever you see, that's focused. Let's see, what else were we going to look at? Give me just a moment. Okay, here's some images that I took in my bathroom with my DSLR. This is just a light panel that I put some foil over the front of and poked some holes in it to make some artificial stars. And I wanted to show you a couple things. Whenever the light panel is in focus here, you can see the stars are small, these little points of light, but I can take them out of focus, they get bigger, right? So when they're in focus, they're small. When they're out of focus, they're big. But not only that, you see the bokeh that we call it here takes the shape of the aperture of the camera, which in this case is round. There is no donut. There's no central mirror obstructing the light path. So it's just a round image. You see these little concentric rings coming out here. But we can change that if we make some modifications to the aperture. You can see now I've got these little stars. This is what the stars really look like. And all I've done here is I've taken the camera and I think I have a picture of it. I put a piece of foil on the front of the lens with a star cut out of it. And that makes those out of focus dots shaped like stars, even though my star is probably a little too big. So when you're looking at an image of something that's out of focus, you're not seeing the true image of that object. What you're seeing is this bokeh, this image that's created by the aperture of the camera system. And there's no way you can dispute this. So if you take a picture of a star and it's big and wobbly and it's got weird donut holes or not, if it's not focused, you're not seeing the star. There's no situation where you can say taking a picture of an object out of focus is somehow giving you a truer representation of that object than it would be in focus. I take a picture of a Coke can and you can see the Coca-Cola logo crisp and clear, and then I take the focus and just knock it out of focus, and so now you can't read the can anymore. What is it? It could be anything. Well, it's kind of can shaped. Maybe it is a can. What's in it? I don't know. You can't see. So being in focus is the only way you can say that you are accurately seeing the object that you're observing. If you want to say that you can take an image of a star, take it out of focus, and somehow you're getting more information about that star than you were getting from seeing it in focus, that doesn't make any sense at all. What other object would you say that about? Would you say that about your grandmother? If you took a picture of your grandmother out of focus, is that what she really looks like? If you took a picture of your dog out of focus, is that what your dog really looks like? This is not something that a sane person would say. If you could just look at things out of focus and get more information about them than you could get by actually being focused on them, why not look at the stars with a seeing eye dog? Wouldn't that get you the most information? I don't see how you can not make that argument. If I said I just have a dog that tells me what the star looks like and now I know more about it than you do, why would that be incorrect? Make an argument. I'd love to hear it. Anyway, I've rambled on about this long enough. If any of you actually watch this to the end, I appreciate it. But let's just drop this fake NASA star, this is what stars really look like argument. It doesn't make any sense at all. Anybody that needs help learning how to use a camera, I'd be more than happy to give you some advice. There's plenty of websites I'm sure you could go to and you could learn how to focus these P900s if you have one. I've seen images people have taken with them. You can actually take images of stars in focus. The autofocus features on these cameras is not made for astrophotography. When you zoom in on a star and it looks at that bokeh image with all the little wiggly lines and stuff and says, well, that looks about focused, it just stops. It's not going to try to focus that down to a point. It doesn't know you're looking at a star. It doesn't have a clue what you're doing. So you cannot expect the autofocus on that camera to get you an accurate focus when you take a picture of these stars. Just because you zoomed in as far as the camera would go doesn't mean you're getting a good, clean image of a star. So learn how to use your camera, and let's all just, if we're going to be seeking truth, let's be sure that the truth is actually what we're seeking and not just seeking to reinforce our beliefs. Because I think there's a lot of that on either side. I'm open to being shown that I'm wrong about something. But you're not going to convince me that this picture here is a better representation of the little light holes that I put in that aluminum foil than the one that was in focus, which looked like this. No, not that one. But anyway, that right there, that's in focus with the star mask on the front of the camera, or close to focus anyway. So that's what I'm getting at when I asked the camera, or I'm sorry, when I asked the question, why is there a donut hole in this star? I was hoping somebody would point out, well, that donut hole is there because there's a central obstruction on that telescope, and that's what's causing that. But nobody did. Scope Man would have gone and spilled the beans, but he didn't. So I appreciate it, Scope. Anyway, y'all have a good night, and I will talk to y'all later.